Hello everyone, so today we are going to Leetcode weekly challenge second question, optimal partition of string. So in this question, we are given with a string and in that string, we are required to partition that string in such a manner into such substrings where in a particular substring there is no repetition of character. So that is the thing we will be going ahead. So that's what I want to say in this question. So this was some overview. Let us read this question and then go through the examples, then the constraint, and then dry run of the same, and then some sort of intuition we can get, and then we will code the same. So now, first thing is that given a string S, partition the string into one or more substrings such that characters in each substring are unique. That is, no letters appear in a single substring more than once. So we are required to have various substrings, and these substrings should be in that manner that once substring if we took, then in that there shouldn't be any repetition of characters, and return the minimum number of substrings in such a partition. So whatever string is being given to us, we would be required to have more than one substring, and those substrings those count of those substrings we are required to return. And these substrings would be those in which if we pick up any substring, then each substring would be having no repetition. So note that each character should belong to exactly one substring in a partition. So each character should belong to exactly one substring in a partition. That simply refers to that here you can see that ABA. Then it is not the valid substring. But if we take only AB, then here it is a valid substring according to conditions given. Then next substring would be AC, right? And one other substring which could be the CA. But the thing is, like CA would be something like means AC is already there and C is also already there. So in that context, it would be like you are already using the same sort of, right? So that's why first we are checking for the A. If we take this example itself, these two examples which are there, so two possible partitions are. So let us check in that direction also. So here, 1 minute. Let us go through the constraints only first. Then I'll go through let us go with the flow. So here we are given with the constraints, right, till 10 raised to power 5. So that simply means that we can use order of n, not order of n square, or even we can use order of n log n. So that is the time limit, you can say time complexity constraint for this question. And then comes the part that all are the English lowercase letters only. So this is all. Now let us go through this particular example. So now you can see that as per the example, A is there, B is there, C, A, B and A is there, right? So A are basically repeating, but these are being separate substrings only. Then you can see A, B is there, A is there, C, A is there and B is there. Here you can see that each substring here, basically all of these are unique ones, right? Nothing is repeating, although A, B and then B, A, but still these all are considered as unique. And even there is any repetition like this, means the way it is here means A are being repeated, but these are separate substrings. So that's why they are being counted. So that was the thing I was trying to say you. So now in this particular, which is being given to us, so let us even take as AB, right? Then if we take as AC, 1 minute. I need to check first. Yes. Here if we take first as the AB, right? And then if we take, because we are counting for the substrings, right? So that's why in that manner only I am saying. And then if we take this AC, right? And then if we ACA, and then if we take B, let us see B. If we take this B, right, and then at the end if we take as this particular A, right? So these all are also basically the different substrings which have unique characters, right? So that's like here we form A, B, A, C, and then A, B, again it was repeated, and then A. But all of them substrings, you can see that in all these substrings we are having all unique ones, right? Any other possibility they have already given to us, like this also we can form, means like while only taking this, or rather than taking AC we can also take A, then CA would be there. So, and as they have already given that AA ever repeated, so like that manner AB is also repeated here. So that is the thing. So only thing which we are required to keep a check is that whatsoever number of substring we choose, but a substring should be in that manner that each substring should have the unique characters in it. You can clearly see that in this particular, this AB, then AC, AB and A, everyone is having unique character in each substring, right? So in that manner only we are required to proceed. So let us check for the other example. In this you can see that whatsoever length we take, everyone would be having what we say means duplicates, right? So that's why when all of the characters are equal, then we would be taking the length of that particular string. Basically we will be having this much number of what we say as substrings. So that's why. So that's the criteria here. Now comes the next part, that how we are required to think about the solution. As you can see that here what we are doing is we are sliding from one character to other and checking that if it is unique or not. Somehow it is sort of sliding window only, right? But in that sliding window also, earlier actually I was thinking to take a map and then also a prefix sum. So in that context we can go ahead with the same, and we will be checking that how much we will be checking that if it was occurred earlier or not. Like it was becoming much more complex. So next what I came up with was with a bitwise solution. So because of bitwise solution only, you can easily able to figure out that if that flag is already set or not. If it was set in this particular sliding window, then we will directly get out of the same. Means basically if it is set at that particular position, then we will be directly coming out of that particular sliding window, and then we'll update our answer that now we got one substring, and then after updating our answer, then we will be resetting our flag, and that's the all thing we will be doing. So the thing is that here we are having A, right? So our flag A has the count of 0, right? But the way we will be doing would be we'll set it as the 1, right? Means basically we do A minus A, right? So we will be getting 0. Means by this 0. This will be in that particular means you all know that A is having the value 0, then B is having the 1. Means like in that manner only. So A if we count from the 0, right, and B we count from the 1, right? So in that context, if we basically subtract A by A, then we will be getting 0. Means A has some sky value, right? And if we subtract it from the sky value of A itself, then we will be getting 0, right? So then if we subtract B from the sky value of A, then we will be getting 1. So like this manner only we can convert them into integer. Basically I am trying to convert them in integer, and then when it is converted into integer, then we are required to set the flag. But one more thing is there which we need to consider here. So the thing is, like see, we will be starting from 0, then we will be starting from 1, right? Now the next part would be that we want to set the flag, right? So how we check that if a particular bit is set or not? If we take the example of there was one question which we always do during the bit manipulation, that if that kth bit is set or not. This is the standard question. So like that manner only we will be doing here. So here we just want to check that if this particular bit which we will be getting here is it set or not? That's the thing which we will be checking. And how we are required to check. So the thing is, for kth element, we used to do something like this. Means k is there, and then kth, not kth any, but the kth bit basically. So how we used to do was like this. For checking that if a bit is set or not, we simply do by this. Means this is the, here we are checking that if I minus 1, this is basically letting us to know that kth bit is ith bit is set or not. That's why we do I minus 1. And then we will be doing this by this, if we take that number as k or n, let us take it n only. So the thing is n and 1 I minus 1, this will let us know that if the ith bit, I don't know why my writing is becoming, it will let us know that if ith bit is basically set or not. So this is the thing which we will be checking by this. So like that manner only we will be proceeding here. Oh, I guess 1 minute. I need to just correct my cursor, because I guess yeah, I was right. It is taking for both of them. That's why the writing is becoming such an issue. Okay. So the thing what I was saying was that if we want to check for any particular bit, then how we do it? We basically do it by doing. क्या हो गया? Okay. In element 10, we want to check if ith bit is set or not. So for that, we basically left shift that bit by I minus 1, and because of this thing only. And when we do and for checking that if that bit is set or not, if we get some answer, that simply means that that bit is set. See, the thing is, when we do and with any particular number, if both of the bits are set, right? So answer will be 1. If both of this bit are not set, if either of them is set, then answer will be 0. Because we all know that A and B is equals to equals to 1 only and only if A and B both are equal. Either A and B both are 0 or either A and B both are 1, then only we will get 1, right? So in that manner only this particular thing works. And why we are taking I minus 1 for ith bit? Because we are left shifting that. Means basically we are left shifting 1, right? And 1 is also at a particular bit only, right? So that's why. So like this only, here this is for the set bit thing. So this, like this way we will be checking that if that particular bit is set or not. Now comes the part about resetting the flag. For resetting the flag, the thing would be, see, when we want to check that that bit is set or not, we require that both of them should be, both those bits should be in same manner, right? And from our side, we will be giving it 1. So that simply means that other side which is there, that should also be 1. Basically, I am saying that that number, say this is that number, and our bit which we are doing from this particular, that is also this, right? So this simply indicates that this particular bit is set, right? If a number is something, say if the number is like this only, and if we give number like this, then here you can see that this particular 0 which is being there, this simply reflects that it is not set, right? So that's why it will return as 0 and this will return as 1. So this simply indicates that bit is set and this simply indicates that bit is unset. So this is the thing I am trying to explain. Now comes the next part, and that next part is for that if that particular is unset. Now basically not unset, but we are required to reset it. So that's the thing. If we want to reset the bit, this will be that criteria when we are able to figure out with one substring and we want to proceed with the next substring, and in that manner only we are required to start from that particular flag again. So in that criteria, the way what earlier we were doing was we were doing and, right, by left shifting by I minus 1 for ith bit. So now what we'll do this or by doing the same thing only. So like this manner, we will be able to reset the bit. So this is the thing we will be doing for resetting our bit. So by using bit manipulation, by resetting and setting the flags, we will be easily able to come up with our answer. Now this was about resetting and getting that particular bit is set or not. And the overview was that when the flag is basically already set, right? So in that context, we will increment our answer and come out and reset. So like this manner only, we will be able to figure out that how many substrings we can get out of this particular, which we got here 4. So this was all for this. Now comes the part about the coding, that how we are required to code this. If bit manipulation is new for you, so no issues. I'll explain that thing also, that how we are required to code this. And yeah, although this is not the code which I actually wrote in the contest, I just was in hurry, so I just took it. But as it is already modelized code, so that's why it is good one. So these are the 3 subparts of this particular code. Now here's the flag. We are starting with I for going ahead for in our while loop, and then our answer, which we are keeping as 1 at the starting, because in the worst case scenario, then all the are unique numbers, then there would be one substring, and that would be the whole string itself. So that's why. Now comes the next part, that we are starting iterating from each character of a string. So here what we are doing, here we are basically converting A to 0. That's the thing which we are doing here. And then here comes the part that here we will be checking if that particular bit is set or not. So for that, this particular function would be called. So this is the same thing which I was saying at the starting. Here what we are checking is, here we basically then we are required to check for ith bit, then we do by I minus 1, means we left it by I minus 1. So here as it is we are passing the n, right? So here we will be checking for the n plus 1 bit, means here when it will be setting it, so the thing is that flag would be set by n plus 1 bit, and it will work for each and every character, right? So because of that thing only, we will be easily able to figure out for every character in same manner only. So that's why it will work. So by this we are able to check means whatsoever we are given, right? So at the first when there is A, right? So our number would be something like this, all 0, because the thing is that particular is 0 only, and we will be checking for n plus 1, right? So at the starting as n would be 0, so things would be something like this, so it will return positive at this moment. But the thing is this also, that at that moment we are just shifting it, right? So at the start it will be ongoing with the set bit only. So that's why here the flag would be set equals to 0 and answer would be incremented, and then we will be again resetting the bit, and here when we are resetting the bit, so it will be something like this only, the way I earlier told, that for resetting we will be doing this thing, means or would be there, or simply indicates that if either of them is set, right? So it will do the same in that flag also. So that's the thing which we will be doing here. Now comes this set is done. Now comes the checking for the next character. So now when we come for the next character, in that we were having this B, right? So for that B again the same procedure will go on, and it will go ahead. Then again the bit would be reset if we figure out that there is nothing reset beforehand, means that particular flag is not set beforehand. So in that manner only. So like this only we will be proceeding ahead. So yeah. Now comes the next part, that what would be the time complexity and space complexity for the same. So you can clearly see that we are not storing anything in the same, right? So that's why space complexity simply becomes order of 1. Now comes the part time complexity. So you can simply see that we are resetting and setting the bit. So that's why, but because we are iterating, so that's why it becomes order of n. But in this particular reset and set, it is already just 32-bit operation only. Means basically order of 32, order of 32, so which comes out to be order of 1 operations, right? So that's why overall time complexity becomes order of n, and that order of n just because of this only, that we are picking up all the elements from this particular string. Means basically as per the here n simply refers to s dot size. So that's the thing. So this was all for this particular question. Hope you like the explanation. If you like it, then please do like and subscribe to my channel, and you can even share among your friends so that the channel gets much more support. So yeah, one more thing is there. Actually, Newton School is also going to start with some coding competitions, about which the link would be in the description below. You can check that out about the whole information on the same, and that will be probably start in the September itself. Although presently the link in the description is about the Newton School full and Newton School SHT, which is some other course, and that course is basically about that you don't need to pay any sort of upfront fee. You just need to pay your fee after your course is completed, and that course is basically about your placements, and that's about that you will get the placement package after this course completion, and that placement package could be from 5 LPA to 40 LPA. That would be completely on the basis of your interview performance in those companies. And the thing is that one-on-one mentorship, your doubt sessions, and your all practice and so on, everything would be done in that particular course. So that's the thing about the course which is being there in description. But about the coding competitions, that would be starting soon, and those link would be also in the description soon, and that I'll let you know whenever it will be out. So you could keep checking for the description and get the whole information from the link. So yeah, this was all about the same. I've already explained space complexity and time complexity also. So let's go ahead for the third question of this particular contest. For time being, this is all for this video. Let's do the third question in the next video. So yeah, this was all. Thank you.